Hi, in this video I'm going to be solving an example on dot products. So we're given this triangle over here with sides u, w and v, angle theta between side u and side v, and we're asked to prove the law of cosines, which is over here. Now I suggest you pause the video and try and solve this problem. It will be a good exercise. So we've been talking about vectors, so this should give you a hint that we're going to be using vectors to solve this problem. So instead of line segments, I'm just going to draw a vector u, and instead of segment v, I'm going to have a vector v, angle theta between them, and then there's a vector w over here. So I'm going to rewrite this using the notation of vectors instead of line segments. This will be the magnitude of w squared is equal to the magnitude of vector u squared plus the magnitude of vector v squared minus 2 magnitude of vector u times the magnitude of vector v cosine theta. Now I want to rewrite this, but instead of having w, I want to replace it, or I want w in terms of u and v. So by looking at this, I see that u plus w is equal to v. As you can see here, tip to tail, tip to tail. So I know that u plus w is equal to v. Now I'm gonna rewrite this by saying that v minus u is equal to w. And now I'm gonna rewrite this equation by using this substitution. So v minus u, the magnitude of v minus u squared, is equal to the magnitude of u squared plus the magnitude of v squared minus 2 magnitude of u magnitude of v cosine theta. Now I'm gonna use a property of dot products which said that a vector dotted with itself is equal to the magnitude of the vector squared. This is one of the properties of dot products. So instead of having the magnitude of v minus u all squared, I can say that this is the same as v minus u dotted with v minus u. And I'm gonna rewrite the right hand side as it is. It's equal to magnitude of u squared magnitude of v squared minus 2 cosine theta. Now we can expand this by saying this is v dot v minus 2 u dot v plus u dot u is equal to the magnitude of u squared plus the magnitude of v squared minus 2 magnitude of u magnitude of v cosine theta. Now I'm gonna reuse this property over here and rewrite it this way. So v dot v is just the magnitude of v squared minus 2 u dot v plus u dot u is just the magnitude of u squared. So, and I'm gonna rewrite the right hand side as it is. Okay, so as you can see, these cancel out over here. These cancel out, and I end up with negative 2 u dot v on the left hand side and negative 2 magnitude of u magnitude of v cosine theta on the right hand side. The negative 2 cancel the negative 2, and I end up with u dot v is equal to the magnitude of u the magnitude of v cosine theta. And this is just one of the properties of dot product, or that's the theorem of dot product. The dot product of u and v is equal to the magnitude of u magnitude of v cosine theta. So this is true. If you have any questions, I'll be more than happy to answer them, and good luck.